Going live. Perfect. So if you're ready, I'm ready. Good.
I'm ready.
Good. And what's up, everybody? We are live. And I think this is the first time my guitar is making an appearance, but particularly because it is a Fender Stratocaster. And today's speaker also uses a Fender Stratocaster, from what I understand. If you have your guitar on hand, Gabriele, you're more than welcome to bring it out.
No.
Not today. That's okay. It's all good. We're chatting about AC/DC. It looks like they might be going back on tour next year, and you really got to get these tour dates in because you don't know how many more tour dates there will be. But speaking of live performances, Gabriele will also be in Detroit on October 24th for DoK Day. If you haven't registered already, why not? Super easy. It's 100% free. You've already got your KubeCon registration. If you'd like to register in person, more details in that link there. We will be there rocking out. And so that being said, our speaker today for our 152nd live stream in just over 2 years is Gabriele Bartolini. You have an interesting job title. You have to explain about that. You also lived in Australia for some time. We have to talk about that too. You've got a really cool t-shirt on. Monash University, if you haven't heard of it, is one of Australia's leading universities, or is the leading university in Australia. Probably.
I really like that university. So yeah,
it's cool. But for the people who don't know you, Gabriele, can you tell us about your job title, because it's an interesting one?
I'm vice president at EDB about the cloud native area. Okay, so cloud native is about running applications in containers using Kubernetes, but it's also about a DevOps culture. Okay, so that I emphasize on the word culture, because that's I think what then leads to using Kubernetes and all these technologies. Without the right culture, I think that everything is bound to fail. Okay, so we need to understand why we're going in Kubernetes, why applications benefit from being in that environment with virtual infrastructures. And so so it's a multi-year kind of endeavor that I've pleasantly started, and I'm really excited.
Very good. And you're doing a great job. It's not every day we have a vice president with us. That's exciting. I'm a fan. But more important,
I don't care about titles.
I know you know. You're a cool guy. You are an ambassador, though, of the city of Prato in Italy. And I would like to know something really quickly, though. Like, what's a typical thing to eat in Prato?
There's so many nice things,
Sure.
And we're really lucky to be here. But one thing that is world famous from Prato, but nobody maybe is aware of that, are the cantuccini. Cantuccini are biscotti from Prato, that they almond biscuits, and they actually come from this city. Okay. So
but in Prato, if you say I want a biscotti, they're not gonna.
They're called biscotti di Prato.
Okay, biscotti di Prato. But if you want to be cool and more local, you say cantucci.
Cantuccini, yes.
Cantuccini. Okay, it's a smaller diminutive. Well, that's good. That's cool.
Yeah.
All right, cool. All right. Well, anyway, we need to do we are doing DoK in-person meetups, by the way. We have one on October 13th in London.
I hope I can organize one in Tuscany.
Yes. Give me an excuse to go to Tuscany, and I will be there. So no, we definitely got to get that spun up.
Yeah.
And also other things going on in Italy. Gabriele and I were talking about this. If you're near Milan in mid-November, I think it's November 17th, 18th, there will be KCD Italy Kubernetes Community Days. And we're hoping that Gabriele is able to give a talk. Gabriele, you're also giving a talk in KubeCon, correct?
Yep. Yeah, I have a slide about that.
Okay, so no spoilers.
No, that's okay. But
we'll about that in a bit. That's
I'm
good.
very excited. Yeah, with Chris Milstead from OnThat.
Yep. Shout out.
We'll talk about Postgres.
Good.
In Kubernetes.
That being said, so like I said, I'll drop the link here for folks that might be in London. Take a look. If you're part of the DoK community and you'd like to do an in-person meetup, wherever you are in the world, let us know. We like to get that spun up. Anyway, Gabriele, that being said, take it away, folks. If you've got questions, feel free to leave them here in the chat on YouTube. If not, always happy to continue the conversation on Slack. Gabriele is one of our best community members. If you want to know how to be a cool person in the DoK, talk to him. Anyway, take it away, man. Go for it.
Thanks, Bart. So
Yep.
let me share the screen.
Okay.
Thank you. And oh, this is Freddie King, my favorite.
All right. If you want, folks, you can also write your favorite blues guitarist in the chat. We can do that as well. I'll put mine. Freddie King, very good player. Interesting way they played with the strap, not over his neck, but just over one shoulder. It was a cool touch.
Sorry.
Yeah.
Yeah, it was huge. That's why. Anyway, unfortunately, I was never able to see him live because he passed away before I was born. But anyway.
The legend lives on.
Yeah. Okay. So I'll start as usual with a question. So when planning for our virtual infrastructure that is based on Kubernetes, do we actually take into consideration the needs of a database system like Postgres? So while you can certainly deploy Postgres databases in an existing Kubernetes cluster, sometimes you might be constrained by the decisions that were made earlier. So this is especially true for on-premise deployments. And the success of our database story in Kubernetes starts from day 0 and goes through day 2 operations. So welcome everyone to DoK webinar 152. And my name is Gabriele Bartolini, as Bart already mentioned. And today I'll be talking about running Postgres databases in Kubernetes with the CloudNativePG open source operator from day 0 operations onwards. So we already talked about my title, but I work for EDB, which is the major contributor to the PostgreSQL open source project. And my purpose is to enhance the Postgres experience in the Kubernetes space. And before I was part of Second Quadrant, which was acquired in 2020 by EDB, and I was there since the start in 2008, and I covered several roles, including head of global support. I've been using Postgres for over 2 decades. That means that I'm getting old. And I've been a member of the community for more than 15 years. I'm also one of the happy founders and proud founders of Postgres Europe, which is a non-profit organization that aims to promote Postgres around Europe. There's actually the major PostgreSQL event in Europe next month, but unfortunately it's the same week of KubeCon. So I'll be in Detroit and I can't be in Berlin with all my Postgres friends. And I say hi to all my Postgres friends that I'll miss. Have a great Postgres conf in Berlin. Anyway, I'm an early adopter of DevOps, big fan of lean, agile methodologies, which, by the way, I was exposed to when I was lucky enough to work in Australia in the early 2000s with one of the most innovative enterprises in the IT sector called Hitwise. And even though I worked there briefly, that really enlightened me with all these agile methodologies. And that was a life changer for me. So yeah, I'm also a big fan of continuous learning, and I'm also continuously studying leadership disciplines applied to software development teams. And finally, I'm an open source contributor. I owe everything I know to open source. So that happens with Linux, with Postgres. And I was lucky enough to contribute to the open source world with Barman, which is a backup and recovery tool for Postgres, and CloudNativePG, which is the topic of this presentation. So if you want, there are some videos of past DoK webinars and talks, also some talks from DoK days during KubeCon. So scan that QR code and you'll be redirected to the playlist from the CloudNativePG YouTube account. So today, after a quick intro, I'll guide you through the operations to run a Postgres database in Kubernetes, from the actual planning, which is called day 0, through to day 2, which is running the database in production. So let's start. But before we do that, I'd like to point to this blog article that I wrote for the last European edition of KubeCon in Valencia. And that goes through the reasons why I believe running Postgres inside Kubernetes is an accelerator for your business. I always say inside because I believe that because of the DevOps principles and values I was mentioning before, I believe that Postgres should run inside the same Kubernetes where applications run. So if you don't know about Postgres, that's okay. Well, that's not okay, but that's okay. But despite being there for a few decades, it does not stop its steady growth in terms of popularity and adoption among large enterprises and developers. So recently, it was voted the most loved database by developers on Stack Overflow. So it's undoubtedly an amazing technology. And if you're new to IT, so if there's new people listening to this webinar, you often hear that SQL is not cool. I actually think that SQL is very cool and can help you a lot during your day-to-day operations. So I strongly recommend that you take some time to study it. And also Postgres offers so many features, and I think that it's a very solid technology on top of which, together with Linux and Kubernetes and Git, could really improve the performance and the productivity in your daily job, and also guarantee you a very good professional growth in your job. So a Postgres database is a complex stateful application. And it becomes even more complex when distributed across nodes to achieve better results in terms of business continuity, for example. So although you can run Postgres as a simple container, I strongly advise against it. So, and if you want to know more, there's an FAQ section in the CloudNativePG documentation that explains that. Anyway, this is where the Kubernetes operator pattern comes into play and helps us, managing these complex applications. So about CloudNativePG, to be honest, there are a couple of popular operators for Postgres, but in this presentation, obviously, I will talk about the one I contribute to, which is CloudNativePG. CloudNativePG is a Kubernetes operator that not only helps us deploy Postgres in day 1 operations, but also orchestrates the full production lifecycle from day 2 onwards. So this is why I think 3 years ago, 3 years ago in 2019, while I was still at Second Quadrant, with my team, we began writing an operator called CloudNative Postgres. Then, after we were acquired by EDB, EDB increased the investments in the operator, and it's been used in production for over a year and a half now by several EDB customers, and also by EDB as the data layer of our database as a service offering, which is called Big Animal. In April 2022, EDB released the operator, the Cloud Native Postgres operator, under the name CloudNativePG as an open source project distributed under the Apache license 2.0. And then EDB donated the IP to a vendor neutral and openly governed community to be built around CloudNativePG. EDB also requested that the project would apply for the CF sandbox process. So we've done so, and we are now undergoing the review process. So hopefully at KubeCon, I'll be able to talk more closely with the community. The latest minor release is 1.17, and 1.18 is on the way. It will be released the week of KubeCon, the week before or that same week. So this is the homepage of CloudNativePG. From there, you can find the link to the documentation, the blog, the Slack channel. So please join our Slack channel to get help and get ideas and suggest, for example, new features. There's Twitter, the YouTube channel that contains the developer meeting recordings, and most importantly, the GitHub repository.
We got a question.
Okay.
Can I run PG auto failover for Postgres, which is running in Kubernetes? We implement also automated failover in the operator itself. Got it.
Okay, so we have built that logic inside the operator. So we use our, for example, I was one of the initial developers of Rep Manager, which was a popular replication manager and failover software. So we pretty much brought that experience inside the operator. So we directly work with the operator itself. But I've got a slide in a moment.
Okay, perfect.
Okay, thanks.
Thank you very much. Good.
So the operator is entirely written in Go. We use KubeBuilder, and I think we've got more than 1,700 commits. So if you have a GitHub account, please make sure you leave a star. I think this morning I checked, we were about to reach 500 stars. I think we were about 490 something. So, you know, it would be cool to reach 500 during this webinar. So we follow semantic versioning. So there's major is mapped to the API version. So right now we're still in the version 1 of the API. Then we've got the minor, which is the second number, and usual, the usual patch release. On our in our documentation, we explain the support policy from the community. So basically, we support the latest 2 minor releases. This is something that we have introduced recently, and these are the currently supported versions of CloudNativePG. So for more details, I put the link as a QR code. So let's start from day 0. Okay, day 0 is about what happens before running things in production. Okay, so when we need to plan for things that will go in production one day. So in this section, I'll go through some of the basic concepts that involve some important architectural and infrastructural decisions for a database. So one common issue that so far we've found, also because, I mean, Kubernetes is new, so we are also learning while we go. So when an organization plans for Kubernetes, infrastructural decisions are taken without considering stateful workloads. But if you want to run a Postgres cluster on it, you need to come to a compromise, especially in terms of performance, if decisions have taken beforehand. But I think that this is not a surprise for us, especially people in the DoK community, because that's the goal of this community, is to shout out and shout loud that Kubernetes, stateful workloads can run in Kubernetes. But first impressions last, and the common opinion is, predominantly that stateful workloads and databases should not run in Kubernetes. So no wonder why in many architectures for Kubernetes, the database is often seen as an external component run as a service by a third party. So although database as a service is a valid option in some organizational contexts. For example, you don't have DBAs. It must be seen as a valid choice. But as I explained in the article that I mentioned before, keeping the database inside Kubernetes has a lot of advantages for an organization that is ready to go through the DevOps journey. Okay, so database people love shared nothing architectures, and it is important to understand that with Kubernetes you can cover the whole gamut of use cases, from the shared architecture to the other extreme, which is dedicated bare metal nodes with directly attached local storage, running a single Postgres instance in a cluster that is managed with Kubernetes. Okay, so this is possible. That's actually, one of the things that we did when we started this project 3 years ago. In March 2019, that's when local persistent volumes were introduced in Kubernetes. And since then, the storage sector has sensibly grown in Kubernetes. And in my opinion, that was one of the main reasons why database workloads have started to appear more predominantly in the Kubernetes space. But in this presentation, there's so much to talk, so I won't cover the storage topic. But it's important to know that it's your choice ultimately. The CloudNativePG supports dynamic provisioning of storage. So as long as you've got, CSI driver and the storage class that supports that, we're fine. Okay. So if you can, try and get local storage, dedicated storage for large databases, but if not, network storage. And if that's the only available option, that's fine. Okay. One important topic is that storage behaves in Kubernetes based on my experience, okay? The same way it does in VMs and bare metal scenarios, okay? The same concepts apply, nothing different. So when you run databases in Kubernetes, you need to apply the same principles that were valid in VMs and bare metal. And if you choose shared storage over the network, you must be prepared for more variability in performance. But as I said, in many cases, that's okay, because the advantages are others, when you run things in Kubernetes. But on this topic, as I was saying at the start, I'm very happy, to say that I'll be covering some of these aspects in a talk at KubeCon next month with Chris Milstead from OnDebt. So if you're there, please make sure you attend and you come and say hi to us. Beyond storage, there are also other topics that I won't cover today, but I think they are very important. And again, I will cover some of these at KubeCon, for example, single versus multiple regions, so cross-cluster, cross-Kubernetes cluster deployments, availability zones, dedicated nodes versus shared nodes, connection pooling, applications and databases where to have them, to have them run, microservice or monolith databases. Okay. These are all interesting topics. If you have questions, I'm more than happy to talk through them later or in the chat. Okay, but for now we concentrate on a single Kubernetes cluster that is spanning over 3 availability zones, typically data centers or buildings in the same region. For the sake of simplicity in this presentation, I'll only consider one Kubernetes worker node in each availability zone, each dedicated to run a single instance of Postgres. Obviously, there will be more nodes in which to run applications, but they're not relevant, for the scope of today's presentation. Yes, Bart?
Yep, you got another question? So how does Postgres work on Knative service and on Lambda function, like serverless ENVI?
I think there's actually a project from some Postgres developers. I don't remember the name, but it's a serverless Postgres. But I think it works fine. I mean, you put Knative on top, and you can write your own Lambda functions that use the Postgres database. So I think it's I see these as a backend of Knative. I don't know if that helps.
If it doesn't, we can get another follow-up question on that. But for now, that
Yeah.
should be good. Thank you.
No worries, thank you. I'll come up with the name of that project.
Okay.
Yeah, it's by, I think, Heike Linnan-Kagas is one of the developers of Postgres that is in that project. Anyway, so as far as storage is concerned, I was saying that we'll consider local persistent volumes dedicated to each node and simulate shared nothing architectures. So please keep in mind that the proposed shared nothing architecture and the shared architecture, you know, they are valid options, they are opposites, and you can have, you know, infinite almost shades that you can pick between one end and the other. And you can do that even on a case-by-case scenario. For example, one database can be on shared nothing architecture, another one in a shared architecture with shared storage, for example. Also, you can decide to host multiple workloads, even heterogeneous ones on the same node. Okay, so for example, applications and databases, it's really up to you. What amazes me is that with Kubernetes, all of these is declarative. You know, it comes out of the box. It's got all the resources that enable us to schedule our workloads wherever we want, using, for example, topology key, node selector, affinity, anti-affinity rules, as well as stains and tolerations. So by doing so, we can easily distribute database workloads across different nodes and availability zones. You can also specify how many resources like CPU and memory you dedicate to a given workload and so on. So finally, we assume that in every cluster, we have installed the CloudNativePG operator. And how do you do that? I mean, it's very easy. We have YAML manifest. You just run kubectl apply, which is the Kubernetes way of installing resources in a declarative way in accordance with the infrastructure as code paradigm. There's also more that we can do during day 0, which have an impact in day 2. Remember that most of the decisions we made now will have a very important effect in day 1 and day 2. I'm talking about platforms for monitoring, logging, and certificates. CloudNativePG is designed to natively integrate with Prometheus. We have native exporters for both the operator and each Postgres instance, and they can be customized. There's a slide later in the presentation. Logs are directly exported to standard output and immediately available in JSON format. And that includes also audit logs. And although CloudNativePG is agnostic to the log management solution, it's important to make your infrastructure team aware of this capability. So a common setup we've seen so far is to use, for example, FluentD downstream as a broker to then consume logs and pass them to other log management solutions. Finally, CloudNativePG has a very powerful system for managing certificates. By default, it creates all of them out of the box, but additionally, you can add your own custom certificates through secrets. So for this reason, it's pretty straightforward to integrate Set Manager for a fully automated and centralized system for certificates. So day 1 operations are those that lead to the deployment of the solution in production. So primarily installation, setup, and configuration of a Postgres cluster. So our goal is to create for day one a 3-node Postgres cluster with a primary and 2 standby servers. Okay, so let's suppose this is our goal. So traditionally, what a DBA would normally do here in tandem with the system administrator is to set up 3 Linux virtual machines, install the operating system and the latest minor version of Postgres 14 in each of them. Then initialize the first instance, configure Postgres, configure stream replication, and enable the 2 hot standby servers. Hot standby is the name of the feature in Postgres that enables read operations on the replicas. Okay. So for security, we also want to make sure that mutual TLS is configured and that replicas are authenticated using TLS certificates, so we don't use any password. And further requirements are that each Postgres instance should have 4 GB of RAM. One of these 4 GB should be dedicated to shared buffers, 8 virtual cores, 50 GB of reserved space for PG data using the default storage class. We also need to make sure that the primary is always accessible via the network to the applications. And finally, create a user and a database for the main application that will reside in the Postgres cluster. Obviously, there's more to think about here. For example, backup configuration, high availability, monitoring, logging, connection pooling, and so on. However, for now, let's concentrate on these. Because I've done these in the past, I can assure you that I'm a bit skeptical that these operations could get done in a single day using VMs. Okay, unless of course
with the right kind of coffee, you can do anything.
Yeah, I know, but and Cantuccini, the
biscotti. Yeah, exactly. I didn't want to destroy the pronunciation, but I figure that's an important combo. We do have a question though from Martin, who's a Frank Zappa fan. Big shout out to Frank Zappa. If you have never listened to him, you need to put some Frank Zappa in your life, no matter how old you are, what kind of music. Big fan. But Martin's question is the following. On-prem, most people say only have 2 data centers or availability zones. How would that work?
Seamlessly. You can distribute them in 2 instead of, you can even run it in 1 availability zone. Okay. It's all, business continuity is can be done, in multiple stages. It's all a matter of cost. In this case, for cost reasons, you decide to have only two availability zones. But in my experience, that could be enough. So the good thing about Kubernetes is that you can spread the Kubernetes cluster across these 2 data centers, and with just setting a topology key to availability zone, the operator will automatically try to install Postgres on nodes in 2 different availability zones. So it's transparent for us. So it's all managed by Kubernetes. If you have, a Kubernetes cluster that is spread across these 2 availability zones, which that's what I do, because that's what Kubernetes does. So the next frontier is about multi-region, so cross Kubernetes clusters. Okay, and that we've got, some good stories there, but that's another topic, and that's what I'll cover also at KubeCon. So I hope that answers. So,
I do too, and if nothing else, it gave us a chance to talk about Frank Zappa. So that's always good.
Yeah, good.
That's good.
So the good thing, and that that's the most important one, is that this is how this translates in CloudNativePG. So, everything we said here can be mapped in configuration with this. So basically, the operator defines a resource called cluster with version 1 of the API. And we have adopted convention over configuration. That's what allows us to have minimal configuration in the manifest. And we make some opinionated decisions, but we leave you the ability to change all of them, to override all the settings. So there's an API reference in the docs for this purpose. And with this manifest, basically, we intend to define the desired state of our Postgres cluster. So as you can see, this is pretty straightforward. I want a Postgres cluster called MyAppDB with 3 instances, each with 4 GB of RAM and 8 cores, as well as 50 GB of disk and 1 GB of database cache. That's the shared buffers. So we save this file and call it myappdb.yaml, and we apply it with kubectl apply -f. That's all. Okay. So what happens under the hood is that thanks to the operator, basically we have a desired state for the cluster to have 3 instances, but that doesn't match the current state of the cluster, which is 0 instances. So this triggers a reconciliation loop that reacts with the goal to make the current state match the desired one. So this is, in my opinion, the amazing value of Kubernetes. So CloudNativePG initializes the first PVC, and it runs initdb, which is the application that initializes the primary. Then there could be a second PVC dedicated to write-ahead logs or WAL files, but for now we keep it out. So when the PVC is ready, CloudNativePG starts the pod, and when Postgres is up, it makes sure that the Kubernetes service that identifies the read and write access called myapp-db-w points to the primary instance. So it's worth noting that by default, the operator issues a standalone certification authority for each cluster and issues self-signed TLS certificates for mutual TLS communications. So then, as I said before, we support the bring your own certificates thing, so you can also integrate that with Cert Manager. Then using PG-based backup, it integrates, it creates the second standby, in a similar way, and then it does so with the second standby too. Okay. So there's obviously more happening under the hood. So CloudNativePG automatically creates a service that points to the read replicas and one to any Postgres instance. It also creates and interacts with several resources, including secrets, config maps, roles, role bindings, service accounts, and so on. As already mentioned previously, we follow the convention over configuration paradigm. And you can also place write-ahead logs in a separate volume. And finally, you can import existing databases even outside Kubernetes. So the same procedure can be used to perform offline upgrades and moving, for example, from Postgres 10, which will be soon end of life soon, to Postgres 15, which will be out in 10 days. Okay. So you can also change the configuration of Postgres. I will not go into much detail here, but yeah, that you can change most of the Postgres configuration parameters, also the host-based authentication. CloudNativePG supports changes of configuration. So if we reload the instances. If necessary, we restart, and that's done in a rolling update fashion. And we're also able to automatically manage the update of standby sensitive parameters. So if you know Postgres, you understand that this is a very cool feature and a difficult one to implement. But if you want to know more about importing databases, this is an article I recently wrote, and that shows how to import a database from RDS 10 into a Postgres 14 database that is managed by CloudNativePG inside Kubernetes. So move from the cloud inside, from a DBAS in the cloud to a self-managed database in Kubernetes. And this is how we enable a new volume dedicated to walls. This is very important for performance and also for stability. Anyway, day one has finished, and we have successfully deployed our Postgres cluster in our production Kubernetes cluster in just a few minutes, just using declarative configuration and the same way we did in testing and development. Okay, this is very important. As a result, our Postgres cluster can become part of our infrastructure as code story. So now that the database is in production, day two begins. And this is where traditionally Postgres DBAs, database administrators, bring their contribution on a daily basis. So these operations include backup configuration, backup retention, backup security, recovery operations, minor updates, cluster monitoring, log management, and so on, database monitoring, alerts, But they also include the most dreaded operation of all, which is failover, either manual or automated. So in both cases, you have to configure the surrounding applications and components that access the database, for example, DNS routing, poolers, and so on. This is what happens, in a traditional environment like a VM or bare metal. So already, I think I imagine that you already appreciate the value that Kubernetes with the CloudNativePG operator brings to day one operations. But honestly, I think that if you are using, for example, Ansible or other configuration management tools, you can achieve the same goals. So I think for day one, you could argue that the value of Kubernetes is really there, okay? But in my opinion, it's in day two operations where you appreciate the whole value that CloudNativePG brings into your fully open source stack made of Kubernetes, Postgres in your infrastructure. So I think it's Patrick McFadden that calls these virtual data centers. I think I really liked, when he mentioned that word. And I think moving from virtual VMs to virtual data centers, and I think that's what Kubernetes, really does well. So I think we've got this opportunity. Anyway, the operator simulates the work of a human DBA, especially those aspects that are closer to the infrastructure. So what we've done with CloudNativePG is to transform our long-time experience with running Postgres in production into code by extending the Kubernetes API server as well as the controller to reconcile the current status of a Kubernetes cluster into the desired one for the Postgres part. So in my opinion, the fundamental difference between Kubernetes and traditional Postgres environments is that the Kubernetes API server, in this case, is the single source of truth and the authority for the entire infrastructure. It controls all the resources inside the Kubernetes cluster, as well as their interface outside. And this obviously includes Postgres, and the applications that rely on it, and the applications that Postgres relies on for monitoring, for example. So this explains also why, for example, we don't use Patroni for failover management, nor a pooler at the front of the database to direct traffic to the primary, because we just rely on Kubernetes resources such as services. Okay. So we support, so we built on top of immutable application containers. Okay. So this means that the only way to upgrade an application container is to replace that container with an updated version of the image. We cannot perform YAM update or APT update. Okay. As a result, a minor update of a Postgres version means that the container image of Postgres 14.3, for example, is replaced with 14.4 without touching the persistent volume. The same thing might happen in case of new container images that include vulnerability fixes at the OS and OS libraries level. So CloudNativePG handled this kind of operation similar to the deployments in Kubernetes. We do it in a rolling upgrade fashion. So we first replace one by one all the replicas and then the primary. And we've got two options: to restart the primary or to switch over to a promoted and updated replica. Such an operation can be fully automated, which is the default, or manual. And this is all configurable. So you can decide which one fits you best. Rolling updates are also triggered, as I mentioned before, when we change the Postgres configuration that might require a restart. That doesn't happen for all options. Then for backup and recovery, we used our 10+ year experience with Barman in designing this capability. So we currently support continuous physical backup on object stores with S3, Azure, or Google Cloud compatible protocol, both in public and private cloud. The object store where a CloudNativePG cluster pushes the backup data is called a backup object store. And we support time-based retention policies. So for example, you can specify 30 days. And recovery is a way to bootstrap a new cluster by restoring either fully or up to a point in time, starting from an existing object store, which is now called recovery object store in contraposition to backup object store. Although it is entirely transparent for the end user, we rely on Barman Cloud for both backup and recovery. So thanks a lot to our Barman Cloud friends and developers. CloudNativePG also allows you to configure quorum-based synchronous streaming replication. We do this with two options. This is also very important because it reduces the risk of data loss. This is all pretty much transparent. So I won't go into details, but I leave the slides here. So when it comes to observability, you can clearly see how CloudNativePG has been designed to be part of the Cloud Native ecosystem. And we provide support for Prometheus, which is the standard de facto in this environment. The operator provides built-in metrics for itself, as well as for each Postgres instance. And it also provides a way to customize which metrics to export for every Postgres instance, using declarative configuration in the form of config maps or secrets. The good thing is that you can write your own metrics in SQL using a syntax that is compatible with the PostgreSQL Prometheus exporter. Queries are transactionally atomic, read-only, and executed under the PG monitor rule, which is very safe from a security standpoint. All these metrics will be automatically pulled by the Prometheus installation in your Kubernetes cluster. There's also these two important extensions that we support. So this is what happens under the hood when the Postgres primary has a problem and the readiness probe starts to fail. Kubernetes immediately detects that and asks CloudNativePG for help. The operator decides which one is the new primary, and the instance manager for the selected new primary detects the change and promotes itself. So when the instance is ready to accept write connections, CloudNativePG updates the read-write service to point to the new primary. In case the former primary comes back, the instance manager detects that it's not a primary anymore, preventing the case of split brain at the source. It invokes internally PG rewind to realign the former primary and restarts it as a standby. So once the pod is ready, as you can see, the Kubernetes service is aligned. And here is the last part of today's presentation. I've got some final remarks. So this is a quick peek in the future of CloudNativePG. So we recently launched 1.17. So we try to keep a cadence of a release every 2 months, but we will be anticipating these because of KubeCon. So in version 1.18, we will introduce support for Kubernetes 1.25. We'll also be officially supporting Postgres 15, which will be out, as I said, in the next 10 days. The good thing is that our end-to-end test suite run entirely on Postgres 15 by default. You have to know that we run end-to-end tests for all the supported Kubernetes distributions, times, all the supported PostgreSQL versions. So this is like 15, at least 15 combinations. Okay. We are introducing cluster managed replication slots for a high availability. Replication slots are a technique introduced in Postgres, I think 9.4, to enable standbys to communicate with the primary and for the primary to retain the WAL files that are needed by the standbys, so that if they, for example, are temporarily down, they can reconnect and resync because the WAL files have been kept by the primary. So we have implemented a very nice feature that supports failovers also. So if there's a failover, we are able to keep the status of replication slots on the new primary as well. We will also introduce cluster hibernation, and after that, we'll be working on declarative roles, declarative databases, and declarative table spaces. So as you can imagine, if you're a DBA, your role will change. Okay, will need to be reshaped.
Oh, sorry, sir. We do have a couple of questions.
Okay, yep.
From Tom Crane, can the operator be used to install Postgres extensions such as PostGIS and Timescale DB?
Yeah, okay. I recently wrote an article.
When do you not write articles? You're writing all. You're very busy.
If you type PostGIS Kubernetes, I think you can see it.
I got it 5 days ago.
Yeah, exactly.
You're like the Stephen King of Postgres.
And it can be done in a declarative way. Timescale, I'd like to add that, but it's very simple. Okay, you can look what we've done with PostGIS. Our approach is that because we are based on immutable containers, all you have to do is add a layer to the base image. So use, for example, our container as a base image and add timescale, the timescale extension to that. Okay, so you can do that. Look for custom images in the documentation, and yeah. So I'm thinking of writing, something about these in the future. We're also thinking about adding some documentation.
Okay.
About that. But yeah, you cannot add extensions after, because as I said before, it's immutable. It breaks immutability. Okay. If you want to change, also this is for security. Our containers do not run as root, and we prevent the content of the image to be changed at runtime. So you cannot change the binaries while the container is running. Okay. So this is a security measure. But yeah, it's possible. You can add all the extensions you want.
Okay.
Okay.
Then one other question is, what technology do you recommend for the on-prem object store that this uses?
I mean, I can say that, for example, we did our test with Min.io, but I think we are pretty much agnostic to that, so I'm now, working with the on that guys, to also that will be our KubeCon talk. So I'm really open to explore, storage opportunities, but for us, it's okay. And also I think that Kubernetes is adding a standard interface to object stores, if I remember correctly, in the next versions.
Got it.
So,
okay. Cool. Perfect.
So yeah, basically, I think, as a DBA, we need to change. Okay, Kubernetes forces us to change. That's what happened with me. And change always brings resistance. Okay, so especially if it's imposed. Okay. But in this case, I think every DBA has the opportunity to anticipate this change. We are required to unlearn a bit what we know. That's the difficult aspect, but I think it's a very rewarding and interesting, trajectory that we can run, especially for our professional growth journey. Okay, so I think that understanding first how Kubernetes works is fundamental. So first we need to study Kubernetes, and once we grasp that, it will be much easier. Okay, but there are jobs that will be taken away by the operator and by the automation and self-healing procedures. And the DBA, I think, can focus more on the aspects that are closer to the developer and to the monitoring. For example, monitor the state of the database if indexes are needed. So more on the modeling side and the logic aspects of the database. Then in the future, I think with table spaces, which at the moment we don't support, with multiple volumes, I think that could be very, very interesting in terms of large databases with partitioning and so on. So finally, you can more than welcome to join our project. This is, but even though the project was created, okay, and sponsored by DB initially, please look at our contributing .md file, the license. This is, I mean, our goal is to truly create a vendor neutral and openly governed community. So please participate to the developer meetings. As I said, there are the videos, you can watch them. And the feedback we receive from new users is that they're all excited about this project because it's entirely based, on the Kubernetes system. So we don't use a tool like, for example, as I said, with all respect for Patroni, it's a great tool, but Patroni works also outside Kubernetes. The operator extends the Kubernetes controller, as I said before. It's written entirely in Go. and we have put all the failover logic inside there. For example, we've got a contribution that a user needed to delay the failover, because at the moment, if there's a failure, we immediately issue the failover. They requested to delay this operation, and there's a pull request for that. So from an external user. So we're really happy about that. So as I said, it was sponsored by EDB, so I'm really thankful for that. But we're also looking forward to enhancing the PostgreSQL experience and the full open source stack. Okay, as I said, this is the real benefit is that you have a fully open source virtual data center with applications and databases that reside in the same place. So thank you, and yeah, further questions, please follow us on Twitter _G_Bartolini_ and CloudNativePG, and that's the URL of the project in GitHub.
Perfect. As usual, amazing. And just to repeat what Gabriele was talking about, they're very serious about this being 100% open. And from all the folks that are involved in this project, whether it's Leonardo or also Jonathan, anyways, super cool people that are also in our Slack that you can get in touch with. Some of the younger folks in our community actually created a challenge around CloudNativePG and really enjoyed all the learnings that they extracted from it. So anyway, great folks to meet from many different countries. You can get cool recipes for different kinds of food, great recommendations, different kinds of music, but seriously, it's 100% really in line with being vendor neutral. So definitely check out the different things that Gabriele mentioned. We'll also be sharing the slides. Speaking of slides, can I get you to stop sharing your screen real quick?
Of course.
Awesome. Last but not least, folks, very important link to drop here, apart from all the documentation, some very serious documentation that I will need Gabriele's feedback on. It's a recipe for cantuccini. And we need to find out if it's a good one or not. I'm sure the best ones are not written in English and are written in Italian, but I shared it with my mom and she's excited to make it. I'm going to be in California before KubeCon. So I will see. She's a really good cook, but I'll have to try it. Maybe I can, this can be the challenge. I can try to make some and bring it to Detroit, and then you can let me know whether or not we passed the test or give us some feedback on it. And in addition, I'm very curious to be with Italian people to try Detroit style pizza, because people from Detroit are really proud of it. Probably has nothing to do with the pizza from Italy, but it'll be interesting to try regardless. As usual, though, before we finish up, just want to share what our amazing artist Anka was drawing in the background. We have a lot of cool stuff here, an artistic depiction of all the stuff that Gabriele was covering in his live stream. Very complete, right? We got to see
as usual.
Yeah, no, but I mean, it was a very touched on a lot of different things in the talk, shared some great resources as well too, so plenty of stuff to follow up on. But I really like this, that, you know, showing folks that this can be done, that, you know, the organizations are doing it and the necessary steps. Like you said, there's got to be a cultural element to it. There's got to be an understanding inside an organization about how these things are going to work, and that there will be resistance to change, and that's okay. That's part of the process. So it's nothing personal. Great questions from the audience. And if you got anything else, of course, you can always continue the conversation with us on Slack. Gabriele, I will certainly talk to you before going to Detroit.
Yeah.
But also very much look forward to seeing you and also checking out your talk that you'll be doing with OnTech. So I'll be good.